Hello everyone, and welcome back to MIS 5000 Special Topics in MIS Python Programming. In this module, we're going to demonstrate how to use Boolean operators and conditional logic in the Python programming language. The Module 7 learning objectives are as follows. After this module, you should be able to describe and use the if, elif, and if-else clauses in Python, describe and use the comparison operators in Python, describe and use the Boolean variables and values in Python, and describe and use the Boolean operators in Python. As a review, our textbook, Automate the Boring Stuff with Python, discusses 4 different types of basic logic. In this lesson, we'll be discussing the second. If this condition is true, perform this action, otherwise do that action. Here we have, as a review, an example of the dual alternative selection structure in our flowchart. We have a decision point that checks to see whether or not the light is green, and if it is true, we press the gas, and if it is false, we hold the brake. We're going to be going over how to program this if-else logic in Python in this module. We've talked about Boolean data types already in the flowchart, meaning that we can have 2 results from a decision, either true or false. We can assign a true or false value to a Boolean variable. For example, if we set the value of true to the variable is raining, then it will hold that value of true, or we could set it to false as well. The capital true and capital false are how these Boolean values are represented and written in the Python language. We can evaluate the result of using comparison operators, including the equals, not equal to, less than, greater than, less than or equal to, and greater than or equal to symbols, to see which Boolean value they evaluate to. Each of these comparison operators compares 2 values and evaluates down to a single Boolean value, either true or false. Let's take a look at several examples. We can ask ourselves what Boolean value the following expressions evaluate to in Python, so either true or false. Most of these should be fairly straightforward since we have integers on both sides. That 42 is equivalent to 42, that will evaluate to true. 42 is not equal to 42, will evaluate to false. 42 is greater than 40, will evaluate to true. 42 less than 40 is false. 42 greater than 42 is also false. 42 greater than or equal to 42 is actually true because they are equal. 43 greater than or equal to 42 is true. And finally, 40 not equal to 50 evaluates to true as well. Each of these can be tested in Visual Studio Code or whatever IDE you're using to program Python. Let's take a look at one of these evaluations in Python. We can simply print the comparison to the console and see the result. So for example, we can print 42 is equal to 42. I'm going to save that. When we run it, we see we get the result of true. If we test 42 is not equal to 42, you'll see we get the result of false. We can also use comparison operators on floats and strings as well as other variable types. We can check, for example, to see whether the following strings are equivalent or not equivalent. For example, cat lowercase is equal to cat lowercase, which will evaluate to true. Cat lowercase is equal to uppercase cat, will evaluate to false. This example here is comparing the string cat to the variable cat, which will depend on what value this variable cat is actually holding as to whether it evaluates to true or false. The string dog is not equal to the string cat, will evaluate to true. And then finally, we have these 2 examples. We have the integer 42 being compared to the float 42.0. We will test this in Python to see how it evaluates, as well as the integer 42 is equal to the string 42, which we'll also test in Python. Let's go ahead and test those evaluations. So print the integer 42 is equal to 42.0. Go ahead and take a guess as to whether or not it will be true or false before I evaluate it. And we can actually see in this case that it does in fact evaluate to true. So the integer and the float are equivalent. Now let's test whether or not 42 the integer is equal to the string 42. And we get the result of false, which is to be expected. So again, just be careful when you're using integers and floats together to make sure you understand how they operate. As a reminder, the single equal sign and the double equal sign operate quite differently. The double equal sign operator is checking to see whether or not 2 values are the same. We put 2 different variables or expressions or values on either side, and this will evaluate down to one true or false value. whereas the single equal sign operator is the assignment operator. It assigns the value on the right of the equal sign to the variable on the left. Let's now talk about Boolean operators in Python. So we saw Boolean operators in use in our flowchart. We had several examples that we're going to take a look at in this module. In our course, we're going to take a look at two binary operators, including and or. So binary, in other words, that we are looking at either two variables, values, or expressions on either side, and evaluating down to whether or not the whole thing is true or false. And then finally, we can put not in front of an expression, variable, or value that is singular, and it will also evaluate to true or false. We worked through a truth table in a previous module where we tested to see the different combinations of true and false using and or. Remember that the and operator evaluates an expression to true if both Boolean values are true, and otherwise it evaluates to false. So the only case where and will evaluate to true is if both sides are true. Recall that the or operator evaluates an expression to false if both Boolean values are false, otherwise it evaluates to true. So the only one of these statements that will evaluate to false is where both sides are false. So it operates kind of opposite to how and operates. The statement will be true as long as one of the sides is true. The not operator simply changes whatever the expression would evaluate to in the first place to the opposite. So if the expression is false and you put not in front of it, it will become true. And if the expression was true, then it will become false. So we can test these in Python to see what happens. Not true will become false. Not false will become true. Statements evaluate from left to right, but in this case, we will first pick up not true, which is false. Not false will become true again. Because we have an even number of nots, it will simply evaluate to what is on the right side. Same thing here, that not false is true, and not true is false, so it becomes false again. We can also print these statements to the console to see how they evaluate. For example, print true and true evaluates to true. Print true and false. True and false evaluates to false. We can also put not in front of the statement, but we have to be careful here. It evaluates from left to right. So this will evaluate as not true, which is false, and false. So we'll have false and false, which becomes false. We can run that and test it, see that it evaluates to false. If we want to make absolutely sure what's going on, we can also test the following. So print true or false should give us true. If we add a not in front of it, it will give us false. We can also test something like not true or not false, which would be this side would be false and this side would be true. With or, as long as one side is true, it evaluates to true. We can also combine Boolean and comparison operators, so the and, or, and not, and then all the mathematical comparators. So expressions are evaluated from left to right until one Boolean value remains. So we can actually test these in Python. Here we have in parentheses 4 is less than 5 and 5 is less than 6. So 4 is less than 5 is true, 5 is less than 6 is also true. So true and true will become true. Remember that, again, each will evaluate down to one Boolean value, whether that's true or false. We test this, so we know this side's already true. 9 is less than 6 is false, so true and false will become false. And then finally, 1 is equal to 2 is false, or 2 is equal to 2 is true, so this last statement will evaluate to true. We can go ahead and print those results to test them. So for example, print 4 is less than 5 and 5 is less than 6 should give us true. If we swap this out for a 7, we'll have one side is true and one side is false, so it should evaluate to false. One side is true and one side is false, so if we change the and to an or, it will evaluate to true. Here we have more items to test. 1 is equal to 1 should give us true. Not 1 equals to 1 should give us the opposite, which would be false. 1 equals 1 and 2 equals 1 should give us also false, because this side is true, this side is false. And then the opposite of that would be true. Let's go ahead and test these statements in Python. So print 1 equals 1, of course, gives us true. If we start to add on to this, I'm just going to comment it out. 1 equals 1 and 2 equals 1. We don't actually need the parentheses there because this will evaluate, and the and will take over. So this side is true, this side is false, so we get false because of the and. And then finally, if we add not, let's test it with and without parentheses. So the original evaluated to false. We're going to ask ourselves what this will be. So not 1 equals 1 and 2 equals 1 also gives us false. Let's see what happens if we put the not on this side. So this is just to demonstrate that when we move not over here, what's going on is we have this statement is true. This statement, the 2 equals 1 is false. Not false is true. So we actually have true on one side and true on the other side. So the whole thing evaluates to true with the and statement. This works similarly with the parentheses in this manner, that we get the opposite. So this was originally false, and then this not statement turns it to true, since we're evaluating this entire and statement first and then negating it. So true and false. All together we put a not in front of it, we get true. Here we have examples from the text demonstrating how the flowcharts are turned into Python code. So in this example, we have a single alternative selection structure. We check the decision point, is the name equal to the string Alice? And if it is true, we print hi Alice. So when we only have one option, if it is true, then we set that up in the following way, that this becomes if name is equal to Alice. We add a colon. We make sure we indent the next line to show that it is grouped in this block with the if statement, and add the print hi Alice. We'll talk a little bit more about indentation once we get into our previous flowcharts. If we have dual alternative selection structure, so say we check to see if the person's name is Alice, it's true, we print hi Alice. If it's false, we print hello stranger. The way this looks is similar. We still have our if statement. So if name is equal to Alice, colon, we print hi Alice. But now we also add else and print hello stranger. So a couple things to notice here. After each clause, whether it's if or else, we have colons. And notice that after this decision point, that the true and false branches that lead to if and else are indented at the same level. And anything that we want to evaluate as part of that if or else statement is indented once from that level. So Python is extremely sensitive to those indentations. If we moved the else out an additional indent, it would consider that else to be part of this if statement, and it would throw an error. Finally, we also have our case statement, so the if and elif pattern, where we can lead decision into decision into decision until we get to a default. We have an initial condition, an expression that evaluates to true or false, another colon, and then an indented block of code. Here's an example of a case statement where we start this first decision with if name is equal to Alice, then we print hi Alice. Elif, on the false branch, age is less than 12, then we print you are not Alice, kiddo. We have another elif here. Elif age is greater than 2000. Then we print unlike you, Alice is not an undead immortal vampire. Finally, this last block will also be elif, so elif age is greater than 100. We'll print you are not Alice, granny. This note on escape characters is here so that you can work with certain characters that won't play nice in strings in Python. So for example, if you want to say hi to somebody that has an apostrophe in their name, and you want to include a single quote inside of a string, you can't simply include the single quote because it will think that you're offsetting a string. What you'll need to do is escape the string sequence using the / before the single quote that you want to include in the string. So for example, text is equal to the input, start the string, enter the word, and then in quotes, word. Let's take a look at an example of this. So for example, print, my name is, and then I want to include single quotes. I'm going to use this escape character, so include a /, and then type my name with another escape character and slash, you'll see that I have to still end the regular string. So I just need to make sure that my punctuation is matching up. If I run this, you'll see I get my name is Catherine with the Catherine in quotes. This works for the double quote as well as several other characters. Now let's go ahead and revisit all of the flowcharts we had in the previous module related to conditional logic and Boolean operators. The first of those was the very simple donuts example, in which we prompted the user for the number of donuts they wanted to purchase. We checked to see if that number was greater than or equal to 12 and gave them a discount if that was true. We calculated the total based on whether or not the number of donuts was greater than or equal to 12, and then returned the total price as output. Let's go ahead and take a look at this example in Python. The first thing we do is get input from the user, and we're going to prompt them for the number of donuts, so that's going to look like this. We'll use the variable donuts, and remember that we have to take care of variable types as we go. Since we want donuts to be an integer, I'm going to use the int function to cast the result of the input function. So I'm going to wrap the input in an int function like so, and then write my prompt. So there is our equivalent statement to this parallelogram getting input. The next thing we're going to do is set up that dual alternative selection structure, the if and the else. Each time I have a decision like this, unless it is a case statement, I'm going to have an if on the true side and the else on the false side like so. So I have if, you may use parentheses if you like. So for example, donuts is greater than or equal to 12. It's not required, however, so I'm going to just remove that. So if donuts is greater than or equal to 12, colon. Now it's red because it's expecting me to put a statement after the clause. Notice that when I put the colon after the end of the if clause and hit enter, that it automatically indents. So what's going to happen is whatever I want this if statement to do, I'm going to have to make sure that it's indented at this particular level. Let me show you an example. So if donuts is greater than or equal to 12, I'm not going to finish this out. I'm going to do some testing to show you what will happen. I'm simply going to print the number. So donuts plus, remember I have to cast back to string, donuts inside the print statement. Let's go ahead and test this. So it's asking me for the number. I'm going to put in 12, and since that is true, it evaluates to 12. If I run it again and I put in the number, say 1, which is not true, notice that it doesn't do anything at all. That's because this wasn't true, so it completely skips this logic. If I do the following, however, I add a print statement after that says hello, what will happen is this print statement, because it is not indented with this if statement, it will always evaluate regardless. So once this block is completed and the indent is over, it pops back out to this level and should print hello. Let's test an example. So let's say it is 12. And each time you run something like this, I encourage you to think about what you should get. In this case, because this is true, we should get donuts 12 as well as hello. Let's hit enter, and sure enough, I do get this print statement as well as this print statement. Let's go ahead and now correct this to match the flowchart. So if donuts is greater than or equal to 12, I'm going to have total is equal to donuts times 1.25. The other side will turn into an else, like so. So else with a colon. Again, making sure that I indent after it, so whatever I want to be in that else block will be indented at that level. Total equals donuts times 1.5. And then notice that the true and the false branches come back together, and then we get the output statement. So rather than putting the print statement here at this level, where it would be only inside the else block, I need to make sure that I bring it back to the original indentation level before printing. So we're going to print the total price is recast as a string, and then the total. So let's go ahead and test this a couple of times. So if the number of donuts is 12, I should get that discount, which I do. The total price is 15. If I run it again with one donut, I get 1.5. So again, each time you have a decision point like this, unless you have a case statement, you're going to have if on one side and else on the other. We can also nest if statements. So for example, if I have a decision running into another decision on only this side, then I can use another if statement within that block. Let's take a look at the example with the invalid input. So I actually reassessed this particular flowchart and it now looks like this. So we first again prompt the user for the number of donuts. We first then check to see if the value is greater than 0. And if it is, then we follow up with, okay, is it also greater than or equal to 12? This is going to allow us to nest if statements in a cleaner fashion. So let's take a look at how this plays out. We start the same way, where we set donuts equal to cast as an integer the input of donuts. No change there. We then start our if else. So again, each diamond is going to change into an if and an else. So the true side is going to look like this. If donuts is greater than 0, we will go on to this. But before I do, what I'm actually going to do is I'm going to set up the else on the other side. And I'm going to make sure I do it at that same indentation level. So of course I'm getting errors right now because I didn't fill in the text below each block. But what I'm trying to show you is that for each decision, you've got if on the true side and else on the false side, and they should be indented at that same level. So we will continue with this if in a second. The else is quite simple. If the number of donuts is 0 or less, we're going to tell them that they put in invalid input because we want them to input a whole number for the donuts. If you want to get technical, a natural number. So print invalid input. So this will only trigger if donuts is 0 or less. That actually takes care of both sides of the branch without going any deeper into it. So we simply have if else at the same level, true on one side, false on the other. Now we're going to address what happens on the if side if it is true. So if donuts is greater than 0, the next thing we're going to do is, notice again, I indent it out. I'm now going to, because I have another decision, add yet another if else inside of here. So I'm going to say if donuts is greater than or equal to 12, then I'm going to do this side of the logic. I will also again have an else, like so. So the if side will have this process here, where total equals donuts times 1.25. On the else side, I will have total equals donuts times 1.5. I now have taken care of this first input prompt. This if else, again, notice at the same indentation level. I've also taken care of this if else, which is at this indentation level. The last thing I need to do is print out the total price. And notice that the way this is set up now, that the total price will only be printed if the number of donuts is greater than 0. So we only have it on this true branch. In order to make sure that that stays true, we're going to keep it at this indentation level, like so. So we'll have our print statement here. The total price is plus recast the string total. And so let me address this one more time. So basically we've got our first statement, which is just this input parallelogram. This first diamond we have represented with this if statement and this else statement, which are at the same level. This one leads into another if else, like so. And then after this if else completes, we come back into this if block on this side, so at this indentation level, and we print the total price. So again, the total price will only be printed if this clause is true. So let's do some testing now. So let's say the number of donuts is 0. I simply get invalid input. This entire block is skipped, and it goes directly to the printing of the invalid input. Let me test the other possibility. So let's say I order 1 donut. We get this else statement to trigger. So we get 1.5 and the total price is printed. We can also test the number 12 and we do get this if statement evaluated and then this one, and then we print the total price of 15. So I think the challenge here, if you haven't worked with code in this way, is to just remember what level you're at when you're using these statements. So anything that falls underneath at a specific indentation level, this statement will be evaluated. It's going to be up to you to manage the indentation in Python to understand when a statement will actually trigger. This is where, again, thinking about the little robot cruising down the flowchart is useful. Because if the robot discovers that the donut value is 0 or less, it's going to take this branch and it will never have an opportunity to print the total price. This is represented using this else statement here, in which all this other logic is skipped if donuts is 0 or less. I will go ahead and post this example to Blackboard. Let's go ahead now and look at the case statement. So remember that we had an example with selecting a letter grade based on the number of points out of 1,000. Basically, we asked the user for how many points they earned. We then calculated the percentage and chose a letter grade based on that percentage. So if it was 90 or above, we got an A. If it was 80 but less than 90, we got a B. 70 but less than 80, we got a C. 0 but less than 70, we got an F. And anything else would simply not give us any assignment for letter, which in this case we could actually take care of. But if we follow the flowchart to the letter, we will not get this statement to actually print. We'll get an error if for some reason the percent is less than 0 or something else. So we're going to start at the top with the parallelogram. We're going to have a prompt here. So we're asking them for the number of points earned, which in this case is going to be an integer. Could also be a float. That's up to you. So I will have earned equals, I'm going to use an integer. Prompt them using points earned, like so. Next, I'm going to calculate the percent based on the value of earned. So I can simply copy this from the flowchart. That percent equals earned over 1,000 times 100. Remember that all division like this is float division, so percent will become a float value. Next, we have our cases. So we're going to use if, elif, and else for this. Let's start with the first one. So if percent is greater than or equal to 90, again, it's going to indent for me. I'm going to set letter equal to A, come back to the original indent, and this time instead of another else, because I lead right into a decision, I'm going to use elif like this. So elif percent is greater than or equal to 80, letter equals B. Another elif percent is greater than or equal to 70, letter equals C. Elif percent is greater than or equal to 0, letter equals F. And finally, I have an else that doesn't lead to anything. If I wanted to add to the flowchart just to make sure that letter had a value, we could do the following, that letter equals U. Again, in this case, I'm actually changing the flowchart just to make sure that we have something for letter in any case. Finally, we come back out to the original indentation level and print the output of letter grade and the letter. And in this case, because the letter is a string, we don't have to recast to a string. Let's go ahead and test this. So points earned, let's say 900, we should get an A. Points earned 800, we should get a B. 700, we should get a C. 0, we should get an F. And finally, let's say we have -10, we get a U. So otherwise, if we didn't add this last else clause, we would get an error because it wouldn't have a value for letter. If you've programmed in other languages, you may be familiar with the case or switch statement. Python does not have the specific case or switch statement, so we can either use this if, elif, method, or we can set up something special using a dictionary once we get to talking about dictionaries in a later module. But keep in mind, in Python, if we're trying to set up a case statement, we're going to use this process. So the if that leads into the elif, that leads into the default case of else. We'll also share this with you on Blackboard. In our previous module, the next example was that of using the Boolean operator of or, and then the Boolean operator of and. So let's re-look at the example. This application indicates to the user whether or not they will receive a discount on their purchase based on the highest priced item in their purchase and the total number of items in the transaction. So if we take a look at the decision point here, we still have that dual alternative structure. But what's different is that we're actually going to use or inside of the decision. And we're going to take a look at the two solutions to this that we had in the previous module. So in this case, we have if the product is greater than 5 or price is greater than or equal to 50. If that's true, we get a discount. Otherwise, we do not. So in this case, we're not using nested statements. We're simply applying or and getting the result. So let's take a look at how this goes. The first thing we have is 2 prompts for the user. So like so, we'll have product is equal to, this is going to be an integer, so I'm going to cast it like so. Products like this. And then another one for the price. This one's probably going to be a float, so I'm going to use the float function to cast this input. And we'll have price of most expensive item. Okay, now we're going to lead into our if else. So our if statement's going to be a bit long here. We have if product is greater than 5 or price is greater than or equal to 50. So we can actually put that entire statement in the if clause and then make sure we also have the else side of things and then add what's going to happen in either case. So if this is true, we're going to print that the 10% discount is applied. And if not, we're going to print that the 10% discount is not applied. Let's go ahead and do some testing. So remember that only one of these things has to be true for this if statement to trigger. So let's test all the possible cases. So let's say we have products is 1 and price is 10. So we should get, in this case, no discount. That is what we get. Say we have products is 1 and price is 50. We should get a discount. Then let's test. So we have 6 products, but 10 was the price of the most expensive item, and we also get a discount. So again, it's important to test all of the cases that you could possibly have, especially when you do have multiple cases based on the Boolean operator. So this is pretty straightforward. You still have if else, it's just that we've added that Boolean operator in the if statement. Now we're going to take a look at the other version of this flowchart where we separate out the or. So remember that in this version of the flowchart, first we check to see if products is greater than 5. If that's true, we automatically get a discount because remember that only one side has to be true for us to get the discount. We then check in the case where products is 5 or lower, whether or not the price is greater than or equal to 50. And if that's true, we get a discount, and if it's not, we do not get a discount. So the only case where we're not going to get a discount is if both of these is false. So let's work through this from top to bottom. First, we have our 2 inputs. So again, products is equal to, I'm going to cast this as an integer. It's actually no change here. Products. Price is equal to, use float again, price of most expensive item. And now I'm going to similarly, so have an if else, but on the else side, I'm then going to have another if else inside of it. So let's start at the top here and take care of this particular decision first. So if products is greater than 5, we have this output. So print 10% discount applied. We then have our following else statement. Again, remember, we need to put it at the same indentation level. We're now going to start a new if statement because this decision leads directly into this next one. So it's going to look like this, that inside this else block, I will have another if else. So if price is greater than or equal to 50, and else something else. So if that is true, we're going to print this same statement. I'm actually just going to copy and paste it, that we do get the discount. And if that is not true, we will not get the discount. So you see that we have if else here and we have if else here. So for each decision point, we actually have an if else statement because we have something that occurs on either side of the statement. The only way we will get no discount is if both products is 5 or less and the price is less than 50. So let's go ahead and test this. So let's say products is 4 and the price of the most expensive item is 10. Again, we get no discount. Let's say we have one product and 50 is the price. We get the discount. Finally, products is 6 and 10 is the most expensive item. We also get the discount. So you see that we were able to break this out into two separate if-else statements, actually a nested if-else, instead of using the or. So whichever option you choose is going to depend on different factors. At this point in this course, you can choose to use either one. Just make sure that if you're asked to follow a flowchart, that you do exactly follow what is in that flowchart. We'll post this to Blackboard as well. The next example was that of using and. So the user gets a discount if the number of products is greater than 5 and the number of purchases they've made is greater than 3. We can actually set this up exactly like we did the or problem, except use and. So we have here an if and an else, and in the if we have products is greater than 5 and purchases is greater than 3. So let's take a look at how this will play out. We first have our input, so products, this is going to be an integer, so I'm going to cast it as an integer. Input products. Purchases is equal to same thing, it should be an integer. Purchases. And now we come to our decision point. So we're going to start if products is greater than 5 and purchases is greater than 3. If this is true, we will then print 10% discount applied. Otherwise, we will print 10% discount not applied. So in this case, both of these have to be true in order to get the discount. We can run a few tests. So if products is, say, 1 and purchases is 4, we should get no discount. If we have 6 products and 5 purchases, we should get the discount. We can test one other case. So let's say we have 5 products, 10 purchases, we also do not get a discount. So remember that in the case of and, both of these have to be true for this to occur. Let's go ahead and take a look at what this looks like in the nested case. I'm going to post this to Blackboard as well. So in this case, it's flipped from the or. We first check to see if the number of products is greater than 5. If that's true, then we also test to see if purchases is greater than 3. If that's true, then we get the discount. And if either one of these is false, we do not. And again, we're going to layer this as nested if else. So this will be our if else at the top. Underneath that if statement, we're going to have another if else. Let's go ahead and put our prompts in again, the same exact way. So products will be an integer. Input products. Purchases, same thing. Input purchases. Now we start our if else for this decision. So if product is greater than 5 and our else I'm going to take care of the else side first. So in this case, we will simply print 10% discount not applied. That's because both conditions have to be true for us to get the discount. On this side, we're going to have another if-else statement. So it'll look like this. So if purchases is greater than 3, then I'm going to take this branch here. So we'll print 10% discount applied. The else will be this false branch. Again, making sure that it's still at the same indentation level as this if-else. In this case, we will print 10% discount not applied. So again, you see that the only case we get this statement to trigger is if both products is greater than 5 and purchases is greater than 3. Let's go ahead and test this a couple of times. So let's say products is 6 and purchases is 6. We do get the discount. Say products is 4, purchases is 3. We do not get it. Products is 3, purchases is 7. Also do not get it. Products 7, purchases 3. We also do not get it. So again, just make sure you are using your if-else statements properly to match each decision and nesting them at the appropriate indentation level. I'll post this example to Blackboard as well. Remember, our last example was where we had a discount if a user was either 12 or younger, 65 or older, and they were also seeing a G-rated movie. So essentially they were either a child or a senior and they were seeing a G-rated movie. So the way this played out was we had several nested decisions. We first asked the user for their age and the rating of the movie. If the movie rating was G, then we went ahead and checked their age. Because remember that we need both the rating to be G and the age to be within a certain bound. If the movie rating is not G, then there's simply no discount. So we're going to have an if-else statement here, another if-else statement inside this if, and on this else side we'll have one more if-else statement. In any case, we're going to either get that the discount is applied or the discount is not applied. Let's go ahead and take a look at this in Python. So first we're going to ask them for their age and the rating, that the age will be an integer. So I'm going to cast that input of age. The rating will be a string, so we don't need to cast there. We can just simply ask for input of the rating. Now we come to our first decision point, so we'll have an if-else. So if rating is equal to G, we're actually comparing against a string at this point. I'm going to take care of the else first, actually. So on this side, the discount is not applied. So we'll just print discount not applied. And that actually takes care of that entire branch. Now we can work on the if side. So under this if statement on this true side, we're going to have another if else like so. So if age is less than or equal to 12, then we will apply the discount. So we'll print discount applied. I'm following this part of the flowchart here. Else, we will trigger yet another if-else statement. So let's take a look at this so far. If the rating is G, and if the age is 12 or younger, we get the discount. If the rating is G, and they are not 12 or younger, we now have to check to see if they're 65 or older. So on the else side, we'll have this final if-else, where we have if age is greater than or equal to 65. I'm on this branch. We will print discount applied. Otherwise, and again, making sure I'm keeping the indentation levels where they need to be, we will print that the discount is not applied. So if you take a look, you can see that every single decision point is represented here. We have the top if-else at the same indentation level. So if the rating's not G, we simply print the discount's not applied. If it is G, we then check the age. If the age is that of 12 or younger, we get the discount. If it's not, then we check to see if they're 65 or older. If they are, they do get it. And if they are not, then they do not. So again, it's just about managing the indentation levels and making sure that you're taking care of every single branch as you go. Let's go ahead and test this. So let's say the age is 12, but the rating is R. We should not get a discount in this case, and that is what we get. Let's say the age is 12 and the rating is G. We do get the discount. Let's say the age is 65 and the rating is G. We also get a discount. And let's check that final case where let's say they're age 32 and the rating is G. We should not get a discount. So we do in fact see that all those cases check out. I'll post this example to Blackboard. If you have any questions about any of these examples, please let me know.